Okay, let's see if we can sort through all this probability stuff going on here. So the first few questions are really trying to discover how many different ways can something happen. So we're actually not dealing with probability and fractions for the first few problems. We're just trying to say how many different ways can something happen. So for the first example, zip codes in North Carolina. Well, we know zip codes are 5 digits long, like 28056 for our school. It turns out in North Carolina, zip codes must start with a 2. Well, if the first number has to be a 2, that means there's only one possible thing it can be. So I'm not putting what number it is, I'm putting how many different things it can be. So if it can only be a 2, there's only one thing it can be. The second digit has to be 7, 8, or 9. That means there are 3 possibilities for the second digit. The 3 remaining digits can be any single digit, so there's no restrictions on the rest of the digits. That means they can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a total of 10 possibilities. So once I get those, I just multiply those numbers together and find out that there are 3,000 possible zip codes in North Carolina. That's called the fundamental counting theorem, what I did right there. Number 2, let's say you have 5 bands to choose from to make a schedule for a radio show. As soon as you see the word schedule, that should tell you that order matters. We do care about order when we're talking about a schedule. So if there are only 3 spots for the bands in the radio show, in how many different ways could you arrange the 5 bands? So since we see the word schedule, that tells us order does matter. That tells us we're dealing with a permutation. We have 5 bands to choose from, and we're going to pick 3 of them to schedule in the show. So we need to do 5p3. So I type in my calculator 5, then go to math, all the way over to probability, and I do number 2, the NPR for permutation, type in 3, and I get 60. So that tells me that the answer is 60. Now just so you know, there's one other way you could do this one if you wanted to. You could say, alright, I've got 3 spots to pick from. I've got 5 bands to choose from. So for my first spot, I have 5 different band choices. But then once I've picked a band, when I'm choosing who goes in the second spot, I'm down to 4 choices. Then I picked 2 bands, so I'm down to 3 choices for who goes in the final spot. If you multiply those together, then you also get 60. So the fundamental counting theorem is very closely related to permutations. But please know it's only permutations that connect with the fundamental counting theorem, not combinations. Which, speaking of combinations, if you look at number 3, it says of 20 possible movies, you plan to take 6 with you on vacation. How many different collections of 6 movies can you take? Well, if you think about it, we don't really care what order we pick the movies in. We may care what order we watch them in, but we're just deciding what to take with us. So in this case, the order would not matter. So that tells us it's a combination. So I would do 20, and I'm choosing 6 of them. So I need to type 20C6 in my calculator. So 20, math, probability, C6, and I find out there are 38,760 different things, different combinations I could pick. Next up, number 6. In a production of The Great Gatsby, 7 actors are trying out for the roles of Jay and Tom. In how many ways can the director cast these 2 roles? If we're talking about a play, the order or the position, in this case the part, certainly does matter. It matters whether we put them in as Jay or Tom. Because of the title of the character, it matters. Because different lines, it matters. Because different personalities of the characters and the actors, it would matter who we choose for which. So this would be a permutation because the order, the position, the part does matter. It's a permutation, and we're trying to choose 2 people to fill those spots. Okay, sorry, my computer slowed down there. We should do 7p2. Go to the same place in the calculator we did earlier, and the answer will turn out to be 42. Okay, so those are dealing with how many different ways we can make something happen, or see something. So starting with number 7, we're dealing with true probability questions, saying what are the odds or what are the chances, what's the probability of something happening. So first, we're dealing with cards. If you randomly select a card from a normal 52-card deck, what is the probability of selecting a 10 or a face card? So we see the word or. That means we know we need to add. So we need to figure out the probability of getting a 10 plus the probability of getting a face card. Well, there are 4 10s in the whole deck, so it would be 4 out of 52. And there are 12 face cards, so 12 out of 52. And we just add those together. So we get 16 out of 52, or that reduces to 4 over 13. And just so you know, they didn't ask us about mutually exclusive or mutually inclusive here, but this would be mutually exclusive because we cannot draw one card and it'd be both a 10 and a face card at the same time. Number 8, determine if the following event is independent or dependent. Then find its probability. What is the probability of selecting a blue marble, not replacing it, then choosing a yellow marble? All right, if we are not replacing it, that means it is dependent. Sorry for the delay. I'm actually writing when I say these things, but my slow computer's having trouble keeping up. Anyway, if you do not replace something, then you are dependent. So we have to think about the fact that we have 8 blue marbles plus 5 yellow marbles for a total of 13 marbles. So it's helpful to write out the equation, which I did, but it won't show up. Let me try one thing. Hold on. It's drawing that line so well. I'm sorry for the delay. Not replacing it means we're not replacing it means we are dependent. So if you do not replace, you are dependent. Oh, I boxed it. It's taking so long. All right, well, I don't think this is going to keep up with me. So, oh, there we go. Okay, cool. Oh, great. And then it disappeared. Very good. Okay, there it's back. So 8 blues plus 5 yellows is 13 total. So they say, what's the probability of selecting a blue marble? Well, that would be 8 out of 13, because there's 8 blues out of 13 total. But since we don't replace it, once we take it out, there's now just 7 blues and a total of 12 marbles. So when I reach in again, the probability of choosing a yellow for the second one would be 5 out of 12. And we are multiplying because it's an and question. We're saying what's the probability of drawing a blue and after that drawing a yellow. So we do 8 over 13 times 5 over 12, which becomes 10 over 39. Number 9, determine the probability of selecting either a face card or a black card from a standard deck. This is mutually inclusive because there are black face cards. You can be both. So we do the probability of a face card plus the probability of a black card minus the probability of something that is both, a black, in that case, a black face card. Okay, there are 12 face cards, so we get 12 out of 52 for the probability of it being a face card. Half the cards, 26 of them, are black, so that's 26 out of 52. And 6 of the 12 face cards are black, because half are red and half are black. So we set that up, and once we reduce that, it becomes 8 over 13. Okay, going over to number 10 and 11 now. They're dealing with this table. So first it says, what is the probability that a randomly selected Californian is Hispanic? So notice we are limiting ourselves to Californians. So what's the probability that a randomly selected Californian, so we're limiting ourselves just to this row right here, is Hispanic? So we want to know the probability of it being Hispanic. So we take the number of Californians that are Hispanic, and we divide by the total population, which is given right here. And we get about 0.324 when we divide that. 9, what is the probability that a randomly selected person from Texas is not Hispanic? Okay, so this one's going to take a little bit more work. So a randomly selected person from Texas. So this time we're limiting ourselves to just the people in Texas. We want to know the probability that they are not Hispanic. So there's two ways we could approach this. One is we could say, all right, I need to know how many are not Hispanic. So I need to take the total population and subtract the number of people who are Hispanic. And then divide that number of non-Hispanics by the total. And this is going down here again. That turns out to be 0.681 or 0.6801, excuse me. So about 68%. Another way you could approach it, if you like that way, that's fine, completely fine, is you could say, okay, well, I want to figure out what percent are Hispanic, or what proportion. So I just divide the number of Hispanics by the total population. And that would tell me how many are Hispanic, which is approximately 0.32. Then I would just do 1 minus that number. Because if 32% are Hispanic, that must mean 68% are not. You can approach that either way. Now, finally, number 12. And the standard deviation. Our first step with these is to plug them in the calculator. So in your calculator, the way you'll find it, you saw it up there, but I want to show you how to get there. You click on Stat, right here in the middle towards the top, and just hit Enter where it says Edit. Now I've already plugged them all in, but you need to, in L1, this very first list, type in all the numbers we see here about the Kentucky Derby. Now you just need one list. I just have the other one there because I'm already ready for number 13. But number 12 is everything in list number 1. Once you have all the numbers plugged in, make sure you double check. You click on Stat, then click on Calc, so move over to the right, and hit Enter where it says One Variable Statistics, the very first option. And assuming you plugged it in L1, which you should have, you just go down to where it says Calculate and hit Enter. So the mean is the very first number we see there, 143.8. The standard deviation is the one that starts with an S, so 15.382. And the median we can find by scrolling down a little bit in the calculator. So you can scroll it down right there. You see the median right there is 148. And the mode, we're going to have to figure that out on our own. The mode is the number that appears most often. So one way you can do that is sort the numbers you plugged in. So if you go back to Stat, you can pick either 2 or 3, doesn't matter. But you can tell it to sort. And then we need to tell it to sort L1 because that's what we plugged all the numbers into. If you look right above the number 1, it says right there L1. So hit second, then the number 1, hit Enter. It sorts those numbers for you. So now when I hit Stat and Edit, the numbers are now in order. So I look for any duplicates. So far I don't see any. Okay, there's 2 151s, and that's it. So the only duplicates I have are 151. So that is my mode, 151, because that's the number that appears more than once. Just a reminder, it's possible for there to be no mode if no numbers repeat. It's also possible to have more than one mode. So if there were two numbers that both appeared twice, they could both be the mode. But this time it is 151. So that covers number 12. Now number 13 works the exact same way, so I'll go through it a little bit quicker. But we go to Stat and then Edit, and I've already got the numbers plugged in L2. You'll want to plug them in, plug them in L1. So you can hit clear, enter, and then type all those in L1. Again, to clear it, you go up to where it's highlighting the list you want to clear, hit clear, and then enter. Okay, so I'm just going to shift the numbers over here. You can just type them in. So now we've got them in L1. So all my numbers for number 13 right here, I've gone to Stat and Edit, then you type them all in. We go to Stat, then Calc, hit one variable statistics, number 1, tell it to calculate, and right there we get most of our information. The mean is 70.92. Find that right there. The standard deviation, that's the one that starts with S, so 13.91. Then if we scroll down, we'll find the median. It is 72. And you can put the numbers in order and find the mode. So I'll hit Stat, Sort, and then hit second, number 1. So that plugs in the list 1 for me. Hit enter. Go back to Stat and Edit, and I can actually see my numbers now. So I'm looking for any duplicates. Okay, I see one. I see there are 2 72s. And that appears to be the only duplicate. So 72 is the mode for that one. Okay, good luck. Feel free to review or rewind and look back at any of this you need to, and do your best.